Hey folks, welcome to Latency and Availability Error Budgets Done Right at Scale. This is a 20-minute talk given in 2020 and recorded on Friday the 13th. Well, let's get to it. I'm Fred Moyer and I work at Zendesk, providers of awesome customer service software. At Zendesk, reliability is feature number 0. If we can't service our customers, they can't service their customers, and then folks get a little bit unhappy. At Zendesk, I spend a lot of time working on service level objectives and error budgets, which we use to measure our service reliability. We've operationalized error budgets in our production systems now for over a year across dozens of services and around 1,000 engineers spread across about 150 teams. Now, this wasn't an easy problem to solve, but our SRE team worked to come up with a solution that was easy to implement. And we're going to tell you about it today. Alrighty. So a quick overview of what we'll be going over. First, a quick error budget refresher, followed by the formulas and implementation details. And finally, we'll look at error budgets across service dependencies. So first, a quick error budget refresher. As we all know, error budgets tell us how much of our customers' goodwill we can use up before they get mad at us. Well, kind of. We set service level objectives, which is a way of declaring how reliable we want our services to be. And we have service level indicators, which tell us if instances of our service quality at that moment are good or bad. Now, each time we encounter an SLI violation, we dip into our error budget a little bit. Notice I didn't say SLO violation, which is like an SLA violation, because that's a one-time event per evaluation period. You violate your SLO when you have exhausted your error budget. And what happens when we exhaust our error budget? We should prioritize reliability work over feature work. This doesn't have to be a step function though. You can spread it out. You can prioritize reliability work at a percentage of your error budget, say when you burn through 50% or 80% of it. It really depends on the evaluation period and the dynamics of your team. So there are a number of publications on SLIs, SLOs, and error budgets that I looked through while doing research for this project. The Google SRE book, which is pretty much the seminal work on the subject, the SRE workbook, and the recently released Implementing Service Level Objectives all cover different aspects of SLOs, SLIs, and error budgets. I read through each of these books closely, and I took the examples they had and put them through the paces through some of the actual implementations that we were looking at. SLOs and error budgets, in theory, are easy to discuss, but when you actually go to put the theory into practice, you find some knowledge gaps that you have to fill in. And I thought all these books did a really good job of discussing the high-level theory and giving some examples, but I found some of the implementation details weren't necessarily as developed as I needed. So there were a couple of other resources I used which addressed these implementation details that I needed to put together. The SLIs, SLOs, SLAs Oh My video by Liz Fong-Jones and Seth Fargo had a really good definition of service level indicators that differed from the books I just referenced and was one that I felt addressed my needs as a practitioner. The Latency SLOs Done Right series of SREcon presentations also had a good number of details that I needed. Quick disclaimer here that I gave one of these talks, but I recommend watching all three, which include versions given by Theo Schlossnagel, the SREcon founder, and Heinrich Hartmann, data scientist. So if you are looking to review prior work on an effort like this, I recommend that you start with these videos for implementation details and turn to the books if you need a broader view on the theory of SLOs and error budgets. Now, error budgets done right is all about the implementation details. So let's get to it and look at the formulas I developed at Zendesk to make these easy to implement across a large engineering team and organization. Alrighty, on to the formulas. So to implement error budgets for 1,000 engineers on a large-scale production system, we have to create patterns that are easy for engineers to understand. We don't want folks developing their own bespoke interpretations of SLIs, SLOs, and error budgets, which happens sometimes at large companies. Folks develop 5 different standards. So we first start with the definition for service level indicators. SLIs are delineations which allow you to classify good requests from bad requests. A good request is one that the user is happy with, and a bad request is one that makes the user unhappy. Now, we've all experienced this. A slow web request or a 500 makes a user unhappy. And so does, an entire website being down. And other things like, you go to your browser and you get a pinwheel. We just, those things are annoying. So let's see how we can codify those definitions. Here are 3 sample SLIs that we developed for our engineering teams. We start with simple examples to make the complex real-world examples possible. Let's walk through this. First, we have a time-based SLI. 95th percentile homepage latency over 5 minutes is less than 500 milliseconds. Now, we all know what that means. A second one is for availability and acts as an event-based SLI. The homepage request response code is not a 500, the dreaded internal server error. And a third event-based latency SLI, the homepage request was serviced in less than 100 milliseconds. Now, each of these statements is slightly different, but they all have common parts that can be parsed out. So let's go ahead and do that. The first piece we find here is that each SLI has what I call a metric identifier, also known as a metric name. And this is essentially a metric in your monitoring system that you record from your service into a time series database using something like StatsD. We all know how that works. The next element is an operator, less than, not equal to, basically any Boolean type operator found in your monitoring system. Again, fairly straightforward, which is what we want this to be. And finally, the third element we parse out is a metric value. This could be a response code, a latency value, or any other value that's stored in your time series database. That's simple. Let's put it all together. Metric identifier, operator, and metric value. You need each of these elements to create a well-formed service level indicator. Now let's take this to the next step and construct SLOs from these. What are service level objectives? They are binding targets for SLIs. I took that statement directly from Liz and Seth's video, SLIs, SLOs, SLIs, oh my. But how can we express that as a formula? For SLOs that represent events for a service as opposed to time-based SLOs, we can represent our SLO as the number of good requests divided by the number of total requests over a time range. Let's take the SLIs that we just saw and transform them into SLOs. We'll take the same type of approach we did before. Here we have 3 matching SLOs to the SLIs we just presented. Let's break them down. First, we'll parse out what can be termed as the success objective. This can be called by a few different names, but it's the percentage that's familiar to folks that have worked with SLOs and SLIs. You know, it could be 3 nines, 2.5 nines, 99.9%. You get the picture. Let's parse on. The SLIs that we created previously are embedded here in those SLOs. As mentioned in Liz and Seth's video, SLIs inform SLOs, and we see that here. Simple stuff. Let's keep going. Our SLOs also need a time period. Without this, the SLO is meaningless. 95% of homepage requests served in less than 100 milliseconds is an SLO I've seen before. But over what time range? I've seen a lot of SLO examples throughout the references that I mentioned, which include the success objective percentage in the SLI, but neglect the period. SLOs are math equations, and you can't just leave off part of them and expect them to work. So keep an eye out for the time period when you're looking at SLOs. Let's put it all together. Success objective, SLI, period. This is the formula for SLOs that we use as a template. But this talk is about error budgets, right? Let's get on to that. So nobody's service is perfect, at least to those of us who have actual users, and then definitely those of us who have a lot of actual users. And developing a formula for our error budget boils down to essentially subtracting our SLO from a value of 1. What does that mean? As an example, if our SLO has a success objective of 99%, our error budget is 1%. We can allow 1% of, quote, bad requests over a given time range before our error budget is exhausted. Let's look at that formula. So it's the same type of format as SLOs to keep things consistent. We've just inverted the success objective. If our success objective was, say, 95%, we subtract that from 1, and now our error budget is 5%. We change the language a bit too. Now we'll say allow X% failure of in place of the success objective, which is followed by our SLI and ends with the time period. Put it all together and you have a template formula for error budgets that 1,000 engineers can all grok at the same time. When folks have a problem trying to develop an error budget for their service, I refer them back to this formula. Error budgets structured this way will allow easy implementation with several commercial monitoring and observability solutions, such that you can send alerts when certain thresholds of error budget burn down are reached. So let's step back for a minute and some of the key points of error budgets at scale. We need simple examples that a lot of people can look at and understand and all be on the same page. We've shown that. We need human parsable formulas that can be codified into commercial and open source monitoring and observability solutions. Remember, we want everyone on the same page. We don't want bespoke implementations across different teams. And we have to be explicit. These are essentially math formulas. They don't work without a time range, success objective, or a well-crafted SLI. So let's finish up these simple examples and put together a complex example from these pieces. Well, the title of this talk started with latency and availability. Let's put together an example error budget that does both combined. So here you can see an SLI, an SLO, and an error budget formula for both latency and availability combined, derived from one of the simple examples we developed. We use a logical OR statement to combine the latency and availability components together. An SLI violation of either latency or availability ticks off part of our error budget. It is important to note here that I'm showing a simple threshold-based SLI for latency. There are definitely better ways of doing this, and I'd recommend reviewing the Latency SLOs Done Right presentations that I referenced earlier. Now let's see how we can actually implement this onto a monitoring system, or observability system if you choose. So at Zendesk, we use Datadog for monitoring and observability. The formulas we developed can be put into Datadog's SLO widget with good events as a numerator and total events as a denominator, and we're able to get alerts when we burn through part of our error budget. And notice here, we've got a target, which is 99.5%, 3.5 nines. That might or might not necessarily be our production value. And we've got a time window, which in this case is 7 days, 30 days, and 90 days. So we have 3 different error budgets for the same service. And we can also see that, in this example, we have a widget that tells us how far we burned through our error budget. In this case, about 25%. Now, the end result here might look simple, but that's what we intended. A complicated solution wouldn't gain us any additional business value, and we would likely end up with teams each having slightly different forms of error budgets instead of everything being in lockstep. And when we have error budgets that all look the same formulaically, we can put those into a large dashboard that we can pass around to executives, product managers to kind of see like where are the weak points, where we need to prioritize reliability, which is the purpose of error budgets. So now that we've covered the basics, let's extend the scope of our discussion to managing error budgets across multiple services. So microservices, SOA, service-oriented architecture, any sort of application architecture that has more than one component, which, unless you're running, a monolith that does in-memory database, is pretty much all of them. So here's a sample application architecture. One question that I've had multiple teams ask me about is how do you manage your error budget when you're a mid-tier service, meaning that you provide functionality to a client-facing edge-tier service, and you have a third-party service that you make requests to, as well as an in-house backend service. This is a standard 3-tier service. That third-party and backend services may occasionally exhaust their error budgets, which affects your mid-tier error budget, and which causes the client-facing edge-tier service to exhaust their error budget since it is dependent on your service. Yes, each of these different points needs error budgets. And your team is caught up in the middle of all this. Your service works just fine internally, but when it makes calls out to the edge, when it makes calls out to the backend service, the third-party service, that's where your reliability goes down, and you don't have control over those services. And you've got the edge tier depending on you and saying, hey, I need more reliability. So let's illustrate this example a bit deeper. So we have an error budget of 1% for our in-house services, and the third-party service has consistently been experiencing a 1% error rate. Our in-house backend service only has a 0.1% error rate. Now the third-party service exhausts the error budget of the mid-tier service, which exhausts the edge tier service error budget. And the burning question now is, which service is responsible for working on improving reliability and decreasing risk. What should happen here? Well, the mid-tier service has a critical dependency on both the third-party service and the backend service, just as the edge tier service has a critical dependency on the mid-tier service. The mid-tier service owners need to find a new third-party service or bring the dependency in-house. And of course, these are blunt options and there are likely better solutions. I'm a big believer in creativity as an engineering superpower. Motivated engineers will always be able to come up with novel solutions to these types of problems. And the question arises, how does one know if the error budget exhaustion is due to the third-party service itself or part of the mid-tier implementation which is not connected to the third-party service? So to determine this, one solution is to maintain 2 error budgets for each service. Let's see how that works. Here we show how we can track error budget usage for the mid-tier service, excluding service dependencies, and also the error budget usage for just the third-party and backend service dependencies. We've assumed here that the error burn is additive from both dependent services, but that might not be the case. It could be you have a fan-out situation where you got, essentially an intersection of those values. And it depends on how your service manages those dependencies. That's an implementation detail I'll leave up to you. But what is clear is that when we traverse the service graph towards the client, the error rates are generally additive. The mid-tier service sees an error rate of 1.2%, 0.1% from its own internal reliability issue, and 1.1% from the backend contributed issues, which exhausts the mid-tier service's error budget. The edge tier sees a total error rate of 1.3%, and it exhausts its own error budget as well. Now, without tracking dependent service error rate contributions to error budgets, we don't know where to prioritize the reliability work. But here, the responsibility of improving reliability is clearly with the mid-tier service owners. We'll need to double the number of latency and availability SLIs to make this happen. One for the overall service itself and one for just the contributing dependent services. The numbers shown on the slide are loose representations of what you might end up with. Now, this can obviously get complicated, but prioritizing expensive engineering resources is worth it. And adding a second error budget for services which essentially have 2 connections is really, I think, the best approach for this, because it allows you to quantify how well each of those dependent services are doing and separate that from actually the reliability of your service independent of those dependent services. Now, I'd like to do a short reflection on the material I've presented. What I've given you folks here is a playbook for error budgets at scale. I've shown the mechanics of formulating SLIs, SLOs, and error budgets in a consistent manner that is hopefully easy to understand. I've talked about a scenario for putting that in place with multiple services across different teams. I've given you the resources to do additional research on the subject matter. But it takes teamwork to put this into practice at scale. Like I mentioned in the last slide, error budgets aren't there to assign blame. Their purpose is to prioritize reliability work. And in a multi-service architecture, which likely describes everyone's architecture here, your overall reliability is only as good as your weakest point on the service graph. So now that you've gotten the tour of this playbook, it's up to you to lead your team on this journey. I hope this information is useful to you. Feel free to reach out to me on Twitter and the SREcon Slack channel. Oh, and also Zendesk is hiring SREs. Look us up if you'd like to work with a group of awesome folks. And that's it. Stay safe out there, folks. And remember, wear your mask.